All right. Great to see all of you. Dave, that was absolutely amazing. And I think I'm going to make the third reference to snow right now. I woke up this morning. I was in the Loire Valley yesterday, 70-degree weather, looking at tulips. I woke up this morning. I knew we had SpaceTech, and it said snow, April 7th, 65% chance. Dave, don't you miss New England? Thank you for a wonderful keynote. You gave us exactly the right frame for this next conversation. Not only the history of the Space Systems Laboratory, but its culture, the combination of technical ambition, hands-on experimentation, systems thinking, and education through building that has shaped generations of students and researchers. We'll now move into our panel, Space Systems Lab, Roots and Branches of Innovation. The goal of this discussion is to reflect on how the SSL grew over time, what made it distinctive, and how its ideas and people propagated outward into industry, academia, government, and new forms of space innovation. Let me invite our panelists to join in. So we have Rebecca Masterson. She's a program office director at the Smithsonian Astrophysical Observatory at Harvard as well. Javier de Luis, founder and former president of Payload Systems. Chung, he's the Bren Professor of Control and Dynamical Systems at Caltech. And then Alvar Saenz-Otero, who's an associate teaching professor of Aeronautics and Astronautics at the University of Washington in Seattle. Please welcome them with a warm round of applause. I'm Ollie de Weck, the program professor of astronautics here at MIT, and I was a PhD student of Dave's, and really it's an honor to moderate this panel. So I've asked each panelist to begin with a short opening reflection, roughly 3 minutes each, on their personal connection to the Space System Lab, why they joined, what drew them in, and what technical or scientific questions animated their work there. And after that, I'll ask each of them a focused question, and then we might have a cross-panel discussion, and then it's your time to ask questions to the panel. And what we're hoping to do here is to paint a live picture of a timeline, not just of projects, but ways of thinking, how ideas moved from concept to hardware, very much what Dave showed us in his keynote, from lab to orbit, but also from one generation to the next. So let's begin with some opening reflections. And I think we're going to start with Javier.
So Dave and I were office mates as PhD students. So we came in at about the same time, was a little bit later. And I guess that why I joined the lab was very much for the same reasons that Dave did. We had this opportunity to fly something on the space shuttle in relatively short order. And we have to remember this was a while ago where space experiments tended to take many, many, many years. And here we were with Mode and then MACE that we could do and make it ours and do it from soup to nuts, sort of. And that was a very unique opportunity for a recently graduated PhD student, that one that I couldn't find anywhere else. And so I jumped at the chance, and we then created this partnership that went several decades and flew all these things, each time building on what we had done before. So I think it was a very satisfying, very successful in the way we did it.
Thanks, Javier. Becky, over to you.
Thanks. You forgot to mention in your email about what we're going to talk about that I'd have to follow a very emotional display of my entire career and time, all the people I worked with. Thank you. I'm totally ready for this now. But
we're here for you, Becky.
Anyway, I actually came to SSL in '97, so I learned today that was the first decade. I had no idea at the time. And I was a mechanical engineering undergrad who decided it'd be fun to play beach volleyball during summer lunches, so I went to intern out in Los Angeles. And I met someone there who had been working with Dave, and when I decided to go for my master's, I had always been interested in space, but had decided to go into mechanical engineering. He connected me with Dave, and I think at the time, Dave was sort of like, who is this person? Like, if it's a mechanical engineering student, I don't know. But the guy was like, no, you should just take her, whatever. So I came, and it was it was like a life, changing experience for me. I was in SSL for 2 years as a master's student, went out to Los Angeles to work for 1 year, and then returned for my doctorate. Went into industry, over to Draper, which is not really leaving MIT, but I count it. And then I actually came back to MIT in 2012 to work with Dave again, and the supportive environment in SSL, I'll say too, when I was first working as this graduate student, I was all like modeling and the simulation, and I felt like I wasn't a real engineer because I didn't build anything, but I was really I got really hooked into the idea of like, can you like model something and then see it actually work out that way? That was super fun. Then when I went to work and I returned to SSL, I got to actually build the hardware for Rexus, and I got to do that part as well. And I was like, oh my God, I forgot how to do simulation. I'm not a real engineer. But it was a fascinating environment to be able to do all of the things that one needs to do to see things succeed in an environment like space. And it just kind of hooked me on doing like really hard things. So it's an experience that really defines me.
Thanks, Becky. That was amazing. Thank you. Sunjo.
Yes, actually, I didn't choose to come to SSL. Actually, I was chosen by Dave, and I think.
So the opposite of me.
Yeah. No, I think it's just, in my opinion, it was kind of miracle. I was really fresh off the boat. It was my first city in the States. I arrived in Logan International Airport. It was my first time in the States. I didn't speak any proper English at the time. Actually, I was picked up by Oli. Oli was my first office mate, and Dave actually was kind enough to send Oli. And I think I want to just say a few words about what I learned from Dave and what kind of advisor Dave was, and a few episodes. Maybe one is that I think Dave's SSL was one of the most active groups at the time when I was there, and I think when Dave was retired, still that was the case. But funding is really tough sometimes, so it was fluctuating. Then I really saw Dave writing his personal check for actually to send his students to travel. I think that was an amazing thing as an advisor can do. Dave actually created some basically playground for us. Dave created a vision, and then he gave us 100% freedom to pursue our ideas. But Dave was not 100% hands-off. He was hands-on advisor. I remember clearly he worked on some math equation on Sunday, and he delivered that, hey, I solved this problem. So I tried to mimic that sometimes to surprise my students. But Dave was really like a father figure to me, brother figure to me, friend. So he was a wonderful advisor, and I learned a lot. And the proof is that when I talk to my students, hey, I have this crazy idea. Do you think it's possible or not? And then I think about someone from Korea, and now I'm a chaired professor at Caltech, and the chances of becoming working with Dave and trying to work hard to get recognition from Dave, that was my motivation to continue to impress Dave. And then I became a chair professor at Caltech. I think the chances of that compared to what research vision I'm talking about, I think that's a lot slimmer. So that motivates me. I can make anything happen. So I learned a lot from Dave. Thank you so much.
Thank you. Thank you, Sunjo. Amazing. Alvar, and thank you both, Sunjo and Alvar, to coming over from the West Coast. We appreciate that. But different part of the West Coast, right, Alvar?
Yeah. North part versus south. So we're, but still the West, and it's very different. So I actually wanted to start not talking about Dave to answer your question. And I'm hoping I'm preaching to the choir. Why did I end up at the SSL? It's called Europe. So for those of you undergrads, I hope I'm preaching to the choir because last I knew 95% of MIT undergrads do Europe. For those of you grad students, actually I got the last. For those of you faculty, keep hiring Europes. That's what makes MIT MIT, because it's this faculty, undergrads, and then right in the middle is the grad students. And grad students, if you've never had a Europe, get one. And I'm sure you heard me. I didn't say, hey, faculty, get Europes. No, grad students, get your Europes to help you with your project so that you can then do all your work for the faculty. And it's amazing. And that's why I ended up in the SSL, because of Europe, because of this opportunity, this structure that MIT creates so that freshmen can be working on things for space. At any year, and if you're a senior and have never done a Europe, do it now. And why do I talk about grad students? Because it was Greg, my mentor, who ultimately introduced me to our faculty member, because as an undergrad, from sophomore, junior, and senior year, I think I met the faculty member 4 times. So that is Dave. He spends all the time with the grad students, which is amazing. Actually, even though I met him over 4 years, maybe 4 times as an undergrad, it was inspiring. It was there. They did not have to be in the meeting with me and Greg to get us to do more stuff. It just happens. So it's the inspiration. It's the inspiration that the SSL created for many decades.
Great. Thank you, Alvar. Wonderful. So now each of you is going to get a specific question to sort of explore a little deeper your relationship with the SSL and how you work together. So Javier, the relationship between Payload Systems, Inc. and the SSL was truly special. It created a bridge between student design work, university research, and the actual space-qualified hardware. That is not easy to do, and it remains one of the hardest transitions in aerospace innovation. From your perspective, what made that relationship work? What were your key takeaways and recommendations for how we can continue to translate ideas from classes and university labs into flight-ready systems in the future?
So I think it's important to answer. I think there are 2 parts to my answer. The first part is that, as you saw for some of the early videos, we were a lot younger then, and it was a long time ago. And it's hard to think about right now when we have things like CubeSats and nanoracks and all these platforms that exist to facilitate getting onto space station or getting into orbit. At the time when we started this, none of that existed. We were basically just a few years removed from Skylab kind of era, and everything was new. You know, we were doing everything for the first time, and that's a lot to ask of a graduate student who, believe it or not, hopefully expects to graduate in a reasonable amount of time. And so Dave and Ed Crawley before that recognized that and brought in Payload Systems to basically handle that part of the work. But that's really hard to do if you don't do the interfacing properly. You know, you got to remember that a university research program not only has science objectives, it also has pedagogical objectives. Very few people come to MIT, I think, to get a PhD in NASA documentation and safety procedures. It's good that you know about them, but that's not why you're here, right? You're here to push the boundaries of human knowledge. And so that's where Payload Systems came in. We would engage with the students, the graduate students, the researchers on campus very early in the program to understand fundamentally what they wanted to do. And then as they continued in the ground development, we would try to translate that into flight qualifiable sets of hardwares and procedures. And that's really the key. You asked what's the key? I think the key is that you have to make sure that whoever you're interfacing with really understands fundamentally what you want to do. Because I've seen so many projects that, you know, the 1 or 2 things happens. They fly, it's great, but they don't get the data that the researcher ultimately needed, or they fly and they don't work. In order for neither of those things to happen, you really have to have that interface start at the very beginning, at the concept of the experiment, and so that is maintained throughout. Now, the world has changed. There are a lot of platforms, and it's easier in many ways to get on into space. However, I would offer that if your experiment doesn't quite fit into the box of a CubeSat, not figuratively and literally, or into a nanorack or whatever, if you're pushing the boundaries, which almost by definition, most of the stuff around here does, it's the interfacing and integration with the spaceflight environment becomes exponentially hard really, really fast. And so even with the facilities that exist today, I think there's still a role to be played for organizations like what we used to have at Payload, because otherwise you spend a lot of time, the university, the students will spend a lot of time doing things that really they shouldn't be doing. Things like MACE, for example, even today I would offer would be quite a challenge to integrate an experiment that big that can shake itself apart and bang an astronaut on the head with a 20-pound gimbaling payload. So,
Great.
not sure exactly how we actually managed to get that flown, but we did.
But you did,
Yeah.
and multiple times even. So thank you, Javier. Becky, over to you. Our favorite topic, the relationship between program managers and systems engineers. It's often described in very simplified terms. Program management worries about cost and schedule. System engineers worry about requirements and technical scope. But in practice, of course, the relationship is a lot richer and sometimes more tense than that. Is it really that simple? How do you think about those interactions?
Yeah, I love this question. I think about this pretty much every day. I think that first thing to think about is absolutely, it's very simple to think of, you get the program manager over here who's only thinking about the money and the when, and you have the systems engineer over here who is thinking about the requirements and the technical scope, and there's a sort of tug of war happening between them. Sure. I think, though, the question is actually missing the third point here, which is the principal, which is the scientist, so, or the PI. So if we're talking about a science instrument, you don't have a line with the PM here and the SC here. You have a equilateral, hopefully, triangle with the PI here and the PM and the SE, and this triangle is very necessary, and the mission lives like in the middle. And you might ask, well, who's in charge in this? The answer is it's the mission that's in charge. We are all trying to serve the mission. Mm-hmm. And the PI is bringing you the why. Why are we doing this? What is the point? So Swati said it actually really, really well in that video where she said, this is the most dangerous crater that we could go to, but this is where the scientists want to see. So why? Where is the bang for the dollars? Why are we doing this? And that's great, but you also then need the system engineer who is the holder of the technical commitment. They're sort of looking at, okay, well, how are we going to make that happen? What are the requirements? How do we take the scientists' vision and actually translate that into a system that we're able to build? How do we manage scope and risk? Risk is also is what the system engineer has to worry about. But then you have the project manager, and they're holding basically the commitment. Okay, we have this vision, we know how we're going to get there, but we need a certain amount of dollars, and we need to get to the launch pad because Bennu's only coming so close to Earth once every 5 years. You got to get there, and so if you don't have these three parts of the triangle, it's very, very hard to get to a successful mission in the middle. There is a certain amount of healthy tension that needs to exist. I could tell you stories about, basically Rexus, and I'll tell a short one, which is more about me and the PI. I will say, so Mark was my systems engineer. You saw him. He's the one that never went out. He was our systems engineer.
And he's the longest bar on the Gantt chart,
He is the longest
right?
bar on the Rexus Gantt chart, yes, yes. He did never go out, but he was amazing. But anyway, but I sort of had to serve as both the technical lead as well as the project manager. So I did a little bit of both of those roles there. And the PI, there was a point at the end where we weren't going to get the science that we wanted to get. We had a problem with our basically noise on the circuit board because I'm a Mechie, so turns out. I was like, well, it's a level one. Our level one requirements were to just educate students. We did that. Let's bolt this thing on and go. The students deserve for this thing to fly. And the PI, Rick Benzel, said no. And Rick and I worked together hand in hand for six years. But it was a tough moment. We both had to advocate. Like I was trying to advocate for cost and schedule and requirements, and Rick was trying to advocate, for science. And we got at the end to the right spot. We did bring the instrument back. I may have cried once or twice. We did take it apart. We fixed the board. We put it back through Vibe, and we got it up there. And we were able to actually open it up and observe X-rays with it. So that was the right answer. But neither one of us could have gotten to it all on our own. We needed that healthy tension and with the trust and respect of each other's your perspective to get us to success. So I do think that the relationship is more intertwined, and it's so important to both stay in your lane, but also to respect what you're being, what you're hearing from your counterparts.
Thank you. Thanks, Becky. Amazing. Thank you for sharing. Sunjo, your work spans a lot of different disciplines. Optics, as we heard about, the arrays, the optical arrays. You work in robotics, autonomy, controls, and AI as well. And so as work that crosses multiple professional communities, we haven't talked a lot yet today about the professional communities, AIAA, SPIE, IEEE, and there's some others. So in that kind of multidisciplinary landscape, how do you determine the center of gravity of a research program? How did you decide that for yourself? Like the unifying questions, so that the work of a lab remains coherent rather than just broad.
Yeah, thanks for the question. I learned all that from Dave. I'm just trying to copy what Dave taught me. Well, I didn't know anything about the optics. I was traditionally trained in aerospace engineering before I came to MIT. But I think, as you can see from all these different projects, you need to go beyond your traditional, conventional knowledge base, whether it's mathematics or computer science or aerospace engineering. And in particular, these days, in my subdiscipline of control and autonomy, a lot of exciting things are happening in the robotics world. And many of actually aerospace people are also present there. So it was kind of natural. And by the way, robotics field likes to see these spheres. So basically, in CDIO, implement and operate. That's actually heavily appreciated. And sometimes even in aerospace doesn't do that in terms of this basically journals and conferences. So it was kind of natural for me to connect to robotics. I think one important question I keep asking is that we are going through revolution, in my opinion, in engineering. I just keep challenged. There are so many things to learn, and I just appear sorry for my grad students actually telling them. I mean, it's a lot more difficult for them to get a PhD thesis these days because, I mean, whatever we had to know, like dynamics and control, and all the fundamental, and we call that good old-fashioned engineering, it's not going anywhere. It's still very important, but still we need to learn so much about machine learning, AI, and so many other things. So it's a challenge. So I try to still apply what I learned from Dave. Sunjo, when I was grad student, Dave was telling me PhD research is all about original, novel, innovative research. So I think we can still compete with the AI on that. For example, my department in Caltech is now called the Computing and Mathematical Science. It's composed of my discipline, Control and Dynamical Systems, Computer Science and Machine Learning, and Applied Math. So one answer is that there is no boundary. I mean, I think still we need the departments because we share some interests. For example, we have a passion for space and aerospace applications. But in terms of core engineering study and so on, I do challenge whether we really need the traditional definitions of aerospace engineering, mechanical engineering, computer science. So that's I just keep thinking about, and I'm happy to be part of this group so that I can learn from all these different thinkings. For example, a lot of innovation in aerial robotics, which is in our field called the drones, autonomous aircraft. Some of the innovative research is happening in the robotics world, and some of them do not have any formal training in aerospace. So we go out and learn from them, but at the same time, we need to also teach them details of aircraft dynamics. So basically, my motivation was to reach out to the different subdisciplines and disciplines and we share the knowledge. So it was natural for me to connect with the different societies.
Thanks, Sunjo, amazing. Alvar, you were the heart and soul of the Spheres program, which became one of the iconic SSL efforts. We saw it in Dave's presentation, 14 years on orbit, an extraordinary platform for experimentation, student experiments, astronaut interaction, and long-duration technology development on the ISS. With the International Space Station currently scheduled for deorbit between 2030 and 2032 sometime, how do you see the future of university-driven microgravity experiments once the ISS is gone? What comes next, and what should universities and agencies be doing now to prepare for that transition?
Great. Okay.
No softballs on this panel.
I was actually inspired by our opening remarks with Dave Mindell to be a part of this question, which is, let's look at history of what happened and then look forward, right? And actually, that question is interesting because we were in the middle of Spheres when the space shuttle retired, and we went through that. And there were some amazing parts that happened because the shuttle returned, and there were some horrible parts. And I think that the space shuttle retirement tells us a lot about maybe we should plan better. We should have things a little bit more ready, because we went through many years of the US having no human capability to space, many of them. And there were some very optimistic people that private industry could just make it happen almost immediately, and we didn't, and that did affect things. And on the other hand, we can see it right now, and actually, I can tell you that when the space shuttle retired, my first year was so angry. I was fierce, and we couldn't, it was so hard to send batteries and tanks up there. It hurt our program. But about a year in, I realized, wait, the United States is the first country that can go to space with private industry. We're still going to space, but it's not private industry, it's not the government. And you think about it, up to now, there's no other country in the world that goes there without the government. I know the little things like the fact that NASA sort of pays most of the budget for SpaceX and Blue Origins, but they pay a lot less. So let's learn from that and let's look forward. I think we're a little bit late. Like, we are not gonna be ready for a space station to be off commission. We are gonna go a few years without space station there. But if we let it happen, and we are ready at least to have the same infusion from private industry, from hopefully half of you guys, because this is about creating space, right? There's a lot of entrepreneurs in here, I think. Well, let's infuse the private industry space station, and maybe we'll get the same leaps and bounds. Because now SpaceX is landing, Blue Origins is landing back. We have tons of startups for CubeSat launches. The same can happen with space station. And I say more importantly, in my head, as a researcher, as a sort of like, let's learn about new things. If we want to go to Mars, low Earth orbit has to be private. In order for we as a country and hopefully as a humanity, we can truly get to Mars, low Earth orbit cannot be a big deal anymore. As much as it sounds, as much as it's awesome to go to space station, it should be boring. Then we can go to Mars. And I think space station retiring will lead us there.
Great, awesome. So we're doing really well on time. So I want to inject a cross-panel discussion question, kind of a meta question before we go to the audience questions. So we heard about the SSL from Dave, and we discussed the individual experiences with it. The theme of today, SpaceTech 2026, is innovation in aerospace. And it's an amazing time. So if we think of the SSL not just as a laboratory, either on Earth or in space, but if we think of the SSL as an innovation model, what's really distinctive about it? You know, the hands-on flight heritage, the systems perspective, the willingness to trust students with real responsibility, the closeness to mission-driven requirements, or something else. In other words, if we take a meta perspective, what can we learn from the SSL as an innovation model to carry to the future? And anybody feel free to jump in.
I think that, you know, all of the above that you listed, but if I were to pick one that I would highlight, it would be the mission focus of the research that was done on SSL. And, you know, a lot of labs get created because they got one big mission. You know, we're going to put one big satellite up or whatever. At SSL and at CERC before that, you know, there was always a lot of different irons in the fire. And that allowed a lot of cross-pollination between the programs, a lot of cross-pollination between the students. I mean, I think that the real legacy of the SSL is not the hardware, or is not. It's the 50 or so or PhD theses. It's the uncountable number of papers. It's all that intellectual bulk that got developed there that went off and spread all over the industry, not just landing rovers on Mars, but doing startups and all this other innovation. But you know, that's a really difficult thing to tell someone that hasn't gone through it that it's going to work. Everyone wants a plan. You know, what's your ROI? What's your 5 year? You can't do that with this kind of stuff. But yet, if you look back, not just the SSL, but other examples of other laboratories or similar organizations, that's their secret sauce, right? They put a bunch of motivated, reasonably smart people together, give them, and let them go. But having the missions prevents it from just becoming an open-ended sandbox. Having the missions, the fact that Bennu only arrives every 5 years, you know, nothing like being hung tomorrow morning to focus your mind the night before, right? That is really what helps us.
Now, you said it's not about the hardware. However, the hardware will be on exhibit at the Smithsonian.
That's right.
Okay, so I don't know how many labs can say that their hardware will be on display at the National Air and Space Museum.
Right, mode,
So
mace,
please
and
tell us a
sphere.
little bit about that, because Dave did not mention that in his modesty.
Sure, the mode, mace, and spheres will be on display in the Smithsonian in their permanent collection, and in the wing that's been remodeled to focus on shuttle and station. If anybody remembers going to the Smithsonian before, it's where the McDonald's used to be. McDonald's is no longer there. And the funny part was when I got asked to find all the hardware, and I found it in the bowels of MIT, and I shipped it down. And then they said, well, how do we put this together? And I discovered that there's a very bright line that's drawn around 1995 or so, whereas before then, but after that, you can find anything on the internet. So I can find any procedure for any, but before then, you just can't find anything. So I said, you know what? I'm just going to fly down. I'm going to show you. And I looked at the old videos, and I reminded myself how it was, and I went down there into the Uberhazy. It's sort of like the room at the end of Raiders of the Lost Ark, you know, where they keep all the stuff. And I got on the floor, and I put the things together, praying that I wouldn't break it. And amazingly enough, after 25 years, it still all went together.
Oh, thank you.
I would just want to add, I think.
Yeah, let's give a hand for that. That's amazing.
So Dave said in his presentation that he learned, I think, from Ed, that if opportunity knocks, that you always just say yes. And I kind of joke that Dave is the person that he could ask me to put an instrument on a spacecraft going to an asteroid, and I'd be like, sure. Like, I basically say yes to whatever he asks me to do. And I think that's actually really important, like that he would give, like, I kind of had no business running Rexus, I'm not gonna lie. And, I remember he called me into his office. I had just gotten back. I didn't write the proposal. He said, Beck, I need someone to liaise with Goddard on this. It's not a big deal, don't worry about it. I just need you to liaise. And I was like, all right, fine, Dave, I can liaise, sure. And I go to my first meeting, and I'm like, oh my God, what are we doing? And I went back to his office and said, you need more than liaising. And, but he put me in that position, and he just trusted me to do it. And I think there's a secret sauce there that's sort of giving people the autonomy, but also the support. Like when I was an undergrad student, I had some dark days. There were times when I was unhappy. And I would set up a meeting with Dave, and I'd go in, and I'd leave the meeting, and I always felt better. Sometimes I'd be like, I think he just hoodwinked me, and I always felt better at the end of it. And so he had this way of like giving you the impossible, but making you feel like you could do it. And I think in any like innovation, that's an important part of what allows people to innovate, is you have to know that it's hard, and you have to know that you have cover of the people that are supporting you, so that you can fail, so that you can screw up, but you can also succeed. And I think Dave really got that just right in SSL.
Great. Should we go to audience questions? Yes?
Sure.
Let's do it. All right. Your time, please. No softball questions. And we need a mic right there. Yep, thank you. And if you would introduce yourself, and then also, is the question for the whole panel or a specific person?
Yeah, so my name is Chase Callan. I'm a first-year LGO Aero-Astro here at MIT. The question for the entire panel is kind of building off a question that you'd already asked Ali on a lot of the work that you guys built your career on in the SSL was in partnership with NASA. And as we have moved towards more privatization of space, what role do you think the university, the institute, and industry have in building and continuing to foster that so that we can learn not just those generic procedures, but how do we continue to innovate in industry?
Okay, let's start here.
Well, that's actually a very loaded question, because industry loves hiring the people that come out of these places. But someone has to pay for that. And I personally believe that while industry is taking a bigger and bigger role in low Earth orbit, like Alvar said, and all that, the role of NASA and other organizations like that cannot disappear. And it's the role that, at least since World War II, the federal government has always done, which is the funding of low TRL, low technology readiness level research, from which all these great things eventually come, but they're hard to predict. So, industry, it's really hard to get industry, especially small industry, startup industry, to cough up money for low-level research and student stipends and things like that. A little bit easier for big companies, I guess. So I don't see the government role going away in the funding of organizations at here. I mean, it's just not the way that industry, especially startups and all that, are able to operate.
Yeah. So without trying to get big political, just skipping it to our industry, if you've been paying attention closely, which not everybody has to, this is not a shame anybody, our industry as a whole has not seen a drop on funding by the government, because it is one of the industries that is known to advance technology constantly. And what I have seen over the past years, since Shuttle retired, like I mentioned, all the way through space station, Danielle Wood is out there still running serial robotics in space station and working with space station that is now handled privately. The government, NASA, even DOD has really embraced the idea of let private industry do it cheaper, and we'll help fund it with projects with what to do with it. So this is absolutely, in my mind, a don't despair situation. The opposite is figure out how are we going to embrace private industry doing for less money, because the government will help us if we use that path. If we try to keep going the path of, hey, NASA, give me $200 million, they won't do it. But if we go to the path of, hey, give me a few $100,000 to go through private industry, actually that they will do. So I would look positive towards it. We are actually in that good part of the world right now for us, leaving the rest aside.
Great. Do we have other questions in the back?
This is Jaime Ramirez. I'm a graduate from the course 16 on 2010 PhD. Yeah. And my question, I think, is more related to, I don't see in the panel a lot of representation of kind of the defense industry base. And I think the SSL also provided kind of some role in making some connections with the defense industrial base at some point. And I want to hear from your perspective, kind of your experiences and what was the role of supporting kind of that important part of the ecosystem.
Yeah, of course, I mean, SSL has a strong connection to supporting the education program with the Air Force. Actually, my personal anecdote is that there is a major Matt McCormick. I actually didn't remember when he was at a grad student, but when he was a test pilot school, he connected me and for some collaboration. And there are a ton of people in DoD who actually graduated from SSL. So I just wanted to share that.
Yeah, on the Rexus side.
Maybe Mike Jones, right?
Yeah, well, more than Mike Jones. I mean, on the Rexus side, we had a number of mostly Air Force folks. One of my students was from the Army. Later, I guess he wasn't Rexus though. Sorry, I'm getting a little bit old, I think. But anyway, we had a lot of Air Force students come through Rexus. They would come off of the FalconSat the program at the Air Force Academy, and they'd come over and continue doing some flight hardware to work with us. And I mean, there was Mike Jones, there was David Lecarte, there was Kevin Stout, there was sort of the Hal Schmidt, kind of went on and on. So that was, I think, mostly the way I think of how the SSL supported the DoD world was through the education of the Air Force students. I've really enjoyed getting a view, and I'm not going to tell the story about my basement, but I'm really close to wanting to. Anyway, so yes, I really enjoyed working with them, and I was always really happy that we had that connection with that part of the government as well. It's important.
And if I could just add a reflection on that, I came here as an international student, right, from Switzerland, and I felt that, and Dave shared about, he was on the Air Force Scientific Advisory Board, so a lot of the technologies that you heard about this morning, of course, have dual use, in remote sensing and precision pointing and all of that. And it is a challenge, I think, going forward to balance, the research funding and the challenges coming from the DoD side versus science. And I think Dave has done an exceptionally good job balancing that and also maintaining a really welcoming environment for international students in particular. So I think we should recognize that.
Dave keeps telling me that I had Alvar University because I kept bringing in a lot of international students for their masters. European universities like to have their masters done outside the university. So I mean, okay, yes, I had maybe a dozen international masters through MISTI program. But if they had stayed here and not been doing all the other stuff, USAFA would have closed and we would have become the United States Air Force Academy for Aerospace because they had so many military cadets at the master's and graduate level. So,
Great.
Yeah.
All right, final question, and then we'll close the panel. And going once, going twice, here on the corner.
Hi.
Is that you, Evan?
Yeah.
Our master urban astrophotographer?
That's right.
That's you.
Hi, everyone. Evan Kramer, current postdoc at Caltech. Dave, PhD student, graduate last year. Question is, we've talked about increasing privatization of a lot of the things in our industry. And so if we take one example, like commercial companies operating, let's say, Earth observation satellites in orbit, these companies now operate the assets that collect the data that are of tremendous value to people like us in the research, public good, education spaces. How do we work to convince them, or how do we operate our own levers to get them to play nice with us? We need their data to do the work we do, and we don't necessarily have huge bags of money to pay them with.
Any thoughts?
The best thing that I could, Yeah, you don't have geometric bags of money, and that's the real problem. Look, spheres, for example. If we had had to actually pay for all the resources that we use on ISS, it would have been a $100 million program, and it was orders of magnitude less than that. But private companies expect to get paid. Silly them. I think that the only avenue open to universities and we're seeing this, not just in aerospace, but the only avenue open is to hopefully obtain some funding and try to come up with partnerships with them of what you're going to use the research for that would somehow benefit them. That's the most successful thing that I've seen. But I mean, I wish there was a better answer. But that is a big problem. I mean, all these, when they talk about private space stations, that's great. I think we're going to go in that direction. But how it's going to be paid for universities, that's still to be decided.
I think there are a couple there are a couple of existing. I'm speaking now through my existing through the role that I have now, but there are a couple of missions. I think some methane sat is one that comes to mind, and Tempo maybe, although I can't remember if that was a private spacecraft or not, where you see this model between like a Smithsonian scientist, and then the spacecraft is pretty sure that methane sat was a private company. So I don't run those programs, and I don't know a lot about them. So I'm speaking a little bit out of expertise here, but I do think there are starting to be some partnerships or some examples of that. So one thing I would do is to go look at those examples and sort of see where that's going. But I agree that there is a conundrum here, because it's sort of what Javier had said earlier. We need the government funding because you need that seed money for when it's not profitable, right? There's no the profit isn't there, but the scientific, but the gain is, and how do we make that case?
Yeah, and I have an answer, maybe more, not all the way to a postdoc level, to the undergrad level, and in 2 words is industry capstone. It's actually what I've experienced it now at the University of Washington. And that's the universities, starting at the very beginning, now need to start thinking more of how they answer to what industry wants, not only to what the government wants. And the industry is interested. It's hard. It's also hard. But we achieve bringing in 3 or 4 industry partners every year to help us with undergraduate capstone. And because we answer one of their questions, they want to spend a little bit of money for them and get an answer quickly, right? So we are going to have to be different. They want it cheaper and faster. And NASA already tried that, so we need to not repeat the same thing, going back to not repeating the same thing. So
great. Yeah. Wonderful. We are at time, so let me close with one brief reflection. What this panel makes clear is that the Space Systems Lab, the SSL, was never only about a set of projects. It was and is a way of connecting ideas to hardware, students to responsibility, and research to real missions. Its roots are deep, but its branches continue to spread through all of your work and our work, through the many people that, Dave, you've influenced and that you showed us. So please join me in thanking our panelists, Rebecca Masterson, Javier De Luis, Sunjo Chung, and Alvar Saenz-Otero. With that, we're going to take a brief break and then reconvene at 11:30. Thank you.